Today we're still looking at surface area and volume. Today we're looking at our last solid, which is a sphere. Your essential question is, how do I apply formulas? Your learning intention: I'm learning to find the surface area and volume of solids. Pause the video and see if you can do the warm-up question now. Can you find the surface area and the volume of this solid? Well, I do hope you tried. So looking at the surface area, we notice that we have a half of a sphere, and then we have a box. We're looking at 15 and we're looking at 10, but we're missing this edge. If I know the diameter of my semicircle, the radius of my semicircle is 6. What is this diameter? Well, we know the diameter will be 12 because the diameter is 2 times the radius. Okay, so we've got all our missing pieces. Let's set it up and let's solve. So for the surface area of the cylinder, it will be 2 times, and the area of the base will be the area of a circle, pi times 6 squared. Remember, our radius here is 6. Our height here will be 10. Plus, my perimeter is 2 pi times 6. That is your circumference of the circle. Then times 10, which is my height. Now that's if I needed the whole semicircle. But I don't. I only need half of it. So at this point, I can easily divide everything by 2. I get 6 squared pi plus 60 pi. And this is about, remember we're going to do an estimation. $301.6. And this would be centimeters squared. Okay, now for the box, what do we notice about the box? Well, one whole edge is covered up by the half of the cylinder. So, as we're looking at our surface area, two times 15 times 12 plus. Now we're going to look at the perimeter hard because we just need 3 sides of it. We don't need all 4 sides. So for my perimeter, instead of going all the way around, I'm going to go over 3, use the 3 sides, and that will give me that lateral surface area. So it'll be 15 plus 12 plus 15 times 10. And I should have put 12 over here, and I put 10. Okay, that's why you double check what you're doing. And I get 780. And this will be centimeters squared. So for my total surface area, it will be 301.6 plus 780 which is equal to 1,081.6 centimeters squared. Okay, if you're still struggling, back the video up and watch it again. For your volume's easier. It's your base area times your height. So as I'm looking at my volume, I've got the semicircle, so that would be pi times 6 squared, that's the area of a circle, and then times your height, which is 10, but I need to divide that one by 2, plus for the box. Now, the volume of the box isn't going to change whether or not a side is covered up. So it will be 15 times my 12, which is my base area, times 10. So to make it easier to put into my calculator, half of 10 is 5, so I'm going to multiply by 5 here. So this is going to be 6 squared pi times 5 plus 15 times 12 times 10. And I end up with 2,365.5 . This time it will be centimeters cubed. Okay, now let's get into spheres. Spheres to me were always really easy because all you needed to know was your radius. A sphere is a set of points in space that are a fixed distance, they're equidistant from a given point called the center of the sphere. Your surface area is 4 times pi r squared. Pi r squared is the area of a circle. And that's r is your radius. So as we're finding the surface area of the following, we know that we need to find our radius. For the first one, the radius is given to us. So my surface area is 4 times pi times 3 squared, which would give me 4 times 3 squared, 4 times 9 is 36 pi feet squared. The surface area is approximately, when I put in 36 pi, I get 113.1. This would be feet squared. Okay, if you can, pause the video and do the next one on your own. The next one, are you given your radius? No, you're given the diameter. If the diameter is 12, then your radius is equal to 12 divided by 2, which is 6. For my surface area, it is 4 pi times 6 squared. Okay, so 4 times 6 squared is 144. And this would be centimeters squared. Okay, what is my approximation? I'm just going to hit times pi, and it is about 452.4. centimeters squared. Okay, if you're struggling, back the video, you can watch it again. Now we're going into application. Emily is placing a gazing ball in one of her customers' gardens. The ball has a diameter of 60 centimeters and will be covered with reflective crystals. One jar of these crystals covers 1 meter. So, if we're looking at this, note that we have two different dimensions. We have centimeters and we have meters. We've got to change one to the other, and because we've already looked at this as being squared, let's turn the centimeters into meters. What is how do you do that? Well, 1 centimeter is equal to 0.01 meters. So my diameter, which is 60 centimeters, will be equal to 6 meters, because you'll move it over 2 spots. So my radius will be equal to 0.6 divided by 3, which is divided by 2, not 3. I gave you the answer there. .3 meters. Okay, for your surface area, 4 pi times 0.3 squared. Now we're wanting an estimation, so we'll put pi in. 4 pi times 0.3 squared, and I get 1.1309. So will one jar cover it? No. She will need 2 jars. Okay, now we're supposed to calculate the surface area to the nearest square centimeter. So this time, we don't need to do the conversion because we know what the diameter is in centimeters. Half of 60 is 30. So we can do our surface area is 4 pi times 30 squared. I'm going to look at 4 times 30 squared to get the exact. And that is 3,600 pi centimeters squared. This is approximately. Just going to take it and hit times pi. 11,309.7 centimeters squared. So if you notice, we did our conversion before we did the problem, because if we tried to do it without the conversion, it would make it very, very, very messy. If you're still struggling, back the video up and watch it again. Okay, volume of a sphere. Volume is simply 4/3 pi r to the third power now. So all you need is the radius. So to find the volume of these spheres, your radius is 7. So my volume will be 4/3 pi times 7 to the third power. So for the exact, I'm going to take parentheses 4 divided by 3 times 7 raised to the third power. And this gives me 457.333. Well, with a repeating 3, that is 1/3. So this would be 457 1/3 pi centimeters cubed. And that is approximately, I'm just going to hit times pi, and I get 1,436.8 centimeters cubed. What about the next one? Do we know the radius on the next one? No, we know the diameter. The diameter is 24, so your radius would be 24 divided by 2, which gives you 12. Now we're ready to apply our formula. So putting it all together, my volume is equal to 4/3 pi times 12 to the third power. This time I'm going to come out with a whole number and then multiply by pi. Do you know how I know? 3 is a factor of 12. So once again, parentheses, 4 divided by 3, close my parentheses, times 12 raised to the third power. 2,304 pi inches to the third power. This is approximately, so I'm going to hit times pi, and I get 7,238.2 inches to the third power. Okay, the volume of a sphere is 792 pi centimeters to the third power. What is its radius? Well, this time we're working backwards. Working backwards is always harder. So I've got 972 pi is equal to 4/3 pi times my radius cubed. So I can divide pi out of both sides. And then I'm going to multiply by 3/4. Remember, we can multiply by the reciprocal to get rid of fractions. Three divided by 4 times 972 gives me 729. What is the opposite of cubing? Taking that cubed root. Okay, in my math button. That math button is very nice. If you look on number 4, I'm taking the cubed root. So I'm just going to hit the number 4. I've got the cubed root, 729, and I end up with 9. 9 is equal to r. Okay. So, as you can see, these get pretty involved, especially if you're working backwards. But at this point in your mathematical career, I hope you can do that. Okay, farmers store wheat in silos to protect the harvest from the weather. Here's a picture of a silo. Determine how much paint is required to paint the surfaces of the silo that are exposed to the weather. 1 liter covers 13 meters squared. If you notice, everything is in meters, so we don't have to do any conversions this time. But as I'm looking at the surface area of the silo, I've got a cylinder and a and then half of a sphere. Do I need the bases of this silo? Am I going to paint what's underneath the ground? No. Do I paint the top of the cylinder? No. So all I'm looking at really is that lateral surface area. So the first surface area I'm going to look at, remember that's 2 times the base plus the perimeter times the height. What is our radius? How can I find the radius? The whole thing is 24. This is 18. So my radius will be equal to 24 minus 18. 24 minus 18 is 6. I've got my radius. Okay, for the perimeter here, it will be 2 times pi times 6 times my height, which is 18, plus 1/2, and this is pi, 4 times pi times my radius squared. Any questions? Okay, putting it in our calculator. We're going to go ahead and do an estimation because we're looking at 13 meters squared. And we have to have that estimation. 2 pi times 6 times 18 plus 1/2 of 4 is 2, so we'll put 2 pi in again, times 6 squared. And we get 904.7, or 0.8. So you would round up to 905 meters squared. So for paint, you would need, if you're going to, first thing you're going to have to do is to take 905 and divide it by 13, because this will give us how many liters we need. And we end up with 69.6. You can't divide a liter of paint in half. and that would be meters squared, you would need about 70 liters of paint. But how much weight would the silo hold if we went clear up to the top? How much would it hold? Well, we've got two volumes to look at, and we know that the volume is your base area times your height for the cylinder, and your volume of the half a sphere is 4/3 pi r to the third. We know our radius, we know the height, so adding them together, for the half the sphere, 4/3 pi times 6 to the third power divided by 2, because we only need half of it. We're going to do that estimation. Then we got to divide by 2. We get 452.38. So we will round it to 452. That would be meters cubed. Okay, so the volume for the cylinder, my base area, pi times 6 squared times my height, 18. This time we need the whole thing. So 6 squared pi times 18. And we get 2035.7. 20,000 or 2035.7 would mean 2036 meters cubed. So my volume is approximately 452 plus 236 and that would be 2,488 meters cubed. They don't tell us how to change a meter into a bushel. That's a good thing, because that's one more conversion that we would have to do, and I don't want to. So, how do you know when you're successful? When you're successful when you can find the surface area and volume of solids. So this is surface area and volume of spheres. So for your surface area, it is 4 pi r to the second power. Remember, your area is squared. For your volume, it is 4/3 pi r raised to the third power. Volume is in units cubed. So hopefully this has been helpful.